In this video, I'll be doing a second example, this time working with the diatomic element oxygen, so an O2 molecule. Again, we're going to start by finding the number of valence electrons that we have to work with for each oxygen atom involved. It's going to be 6 valence electrons. One thing that we could find that from the periodic table, but we can also find it just by doing the electron configuration like we did in the previous example. It's going to again start with helium here, and in this case, finish it off with 2s2. 2p4. And so that'll complete the electron configuration for it. Again, 2 is our valence level, and so we will see that there is a total of 2 plus 4 electrons in the 2 energy level, meaning that we should have 6 valence electrons to work with. So we will draw those in for the starting diagram, which shows our 2 separate oxygen atoms before we have shared any electrons between them. And we'll want to be thinking about how this will change as we try to meet the goals of getting to that noble gas electron configuration. We can do the same kind of process here. So we're looking at oxygen, which wants to look like neon, have 8 valence electrons. And so if we look at our left oxygen atom, it is currently too short of this. In order to get there, we would have to share 2 of the electrons from the right oxygen. So we can take those 2 electrons, put them into the shared region, so that the left oxygen will now have access to them. We're going to have to do the same kind of thing for the right oxygen atom. It still only has the 6 electrons, meaning that it's going to need 2 more from the left. So the left will share 2 electrons with the right oxygen, taking those and putting them in. And our result will look something like this. Since we have used 2 electrons from each oxygen, each of them will only have 4 electrons out of the original 6 belonging solely to them. The others will be in the center, and we'll see 4 electrons shared in there. Again, we want to make sure that everything we did here is on the up and up, so we want to make sure we haven't gained or lost any electrons. We started with 2 oxygen atoms, each with 6 valence electrons, for a total of 12 valence electrons. And counting them up, we have 4 plus 4 plus 4 equals 12 valence electrons in our final version. So this is good so far. We are also going to want to check to make sure that we have an octet for each of these atoms. In other words, each of the oxygen atoms has its 8 valence electrons, which makes it look like the noble gas, in this case, neon. Looking at the left oxygen, we have the 4 it has on its own and then the 4 it's sharing for a total of 8. And we see the same kind of thing with the right oxygen. We have the 4 it has on its own and then the 4 being shared as well. So we have a total of 8 electrons there. We are seeing that they are, in fact, now matching the noble gas neon in terms of their valence electrons. And so this should be a good structure showing the covalent bonding between our 2 oxygen atoms. Again, to wrap things up, we can think about how many covalent bonds this is now showing. So in this case, since we have 4 electrons shared between the 2 atoms, that means that there are 2 pairs of valence electrons shared, or in other words, 2 covalent bonds. So in the case of our O2 molecule, we are seeing that there should be 2 covalent bonds between the oxygen atoms, as opposed to the 1 covalent bond that we saw in the fluorine case. So this gets into a case where we have now seen the possibility for multiple bonds between 2 atoms, and so hopefully this will prepare you for when you see questions like this in the future. Good luck with the homework.